Have you ever wondered how large-scale applications run smoothly across multiple servers? The secret lies in a powerful system called Kubernetes. Kubernetes is an open-source platform that makes deploying, managing, and scaling applications easier. In today's video, we're diving into the architecture of Kubernetes so you can understand how this technology operates behind the scenes. Let's explore what makes Kubernetes one of the most wanted tools in the world of DevOps. First, let's talk about what a Kubernetes cluster looks like. A Kubernetes cluster is made up of two main components: the control plane and the worker nodes. Let's start with the control plane. The control plane manages the entire cluster. It decides where to run workloads, keeps an eye on the health of the cluster, and responds to events. Now, this control plane has several important parts, starting with the API server. The API server is your main point of access. It's where you communicate with the cluster, and it processes all requests for changes. This server is stateless, meaning it doesn't keep track of session data. Instead, it relies on a database called etcd to store the current state of the cluster. Next up is the scheduler. The scheduler has a critical job. It assigns newly created pods to worker nodes. It looks at available resources like CPU and memory and considers various rules before making a decision. This ensures that the application runs optimally and efficiently. Now, let's not forget about the controller manager. This component runs a bunch of controllers that keep things running smoothly. These controllers are like watchdogs, monitoring the system and making changes as needed. For example, the replication controller ensures that a specific number of pod replicas are always running. Then we have etcd. Again, this is the heart and soul of the control plane. etcd is a distributed key value store that keeps a record of the cluster state and configuration data. It plays a vital role in ensuring that all parts of the cluster are in sync. And lastly, we have the Cloud Controller Manager. This part interacts with your cloud provider to handle cloud-specific resources. It makes sure Kubernetes can work seamlessly with different cloud technologies. Now that we've covered the control plane, let's move on to the worker nodes. The worker nodes are where your application actually runs. Each worker node is like a mini-server that will host your application containers. Every node has three essential components. The first is the kubelet. The kubelet acts as an agent that oversees the containers running on that node. It checks their status and reports back to the API server. If any container fails, the kubelet takes action to restart it. Next, we have the Kube Proxy. The Kube Proxy handles networking and load balancing. It guarantees that pods have unique IP addresses and can communicate with each other. By doing this, the Kube Proxy makes sure network traffic gets routed correctly. Finally, there's the Container Runtime. Think of this as the engine that runs your containers. You can use several types of container runtimes with Kubernetes, like Docker and Containered. Once the features of the control plane and worker nodes are clear, let's talk about Kubernetes objects. Kubernetes uses objects to define and manage the state of the applications running in the cluster. The simplest of these objects is the pod. A pod can hold one or more containers that work together. Then we have services, which help manage access to pods. A service acts like a stable endpoint for application users, even when the pods themselves change. Next, we need to mention deployments and replica sets. A deployment manages your pods and defines how many replicas should be running. On the other hand, a replica set ensures that the specified number of pods is maintained at all times, automatically replacing any that fail. For applications needing persistent storage, there's also stateful set. It is similar to a deployment but designed for applications where storage and identity are important, like databases. Now, Kubernetes has a cool feature called namespaces. Namespaces help you organize your resources into different groups, providing isolation for teams or environments. And let's not forget config maps and secrets. These are special objects for storing configuration data and sensitive information like passwords. Next, let's explore Kubernetes networking. Kubernetes has a flexible networking model that ensures communication between all its components. For instance, every pod gets a unique IP address. This means pods can talk to each other directly without issues. Kubernetes also simplifies service discovery. With automatic DNS assignments, pods find each other easily by name rather than IP address. Another vital part of networking is the ingress controller. This component manages external access to the services in your cluster. It defines HTTPS traffic rules to direct requests to the right places. Don't overlook network policies either. These allow you to specify how pods can communicate, helping to secure your applications. Now, let's go through a simple Kubernetes deployment workflow. Step 1 is defining the desired state of your application. You create YAML files that outline what you want. Next, you submit this YAML file to the API server. The API server checks it and saves the desired state in etcd. Then, the scheduler comes into play, deciding the best worker node for your pod. The Kubelet keeps everything running smoothly by ensuring the pod starts up on the selected worker node. As soon as the pod is live, the service is created to provide access via a DNS entry. Finally, Kubernetes continuously monitors the application. If it detects a failure or needs more resources, Kubernetes steps in to fix things. Understanding Kubernetes architecture is like having a map to a vast and complex city. It guides you through how everything works together efficiently. This knowledge makes it easier for you to deploy and manage applications seamlessly. If you found this video helpful, please hit the like button and share your thoughts in the comments below. Don't forget to subscribe for more content like this. Join us next time as we explore another fascinating topic in the world of technology.